Hello friends, welcome to this video. In this video, we'll be discussing this theorem. Theorem is stated as any orthogonal transformation in R2 plane is in reflection or it is nothing but a rotation. So for an orthogonal transformation in R2, there are only two possibilities. It should be either reflection or it should be rotation. In the previous video, we have discussed the matrix representation of this. Let us just revise that. So the matrix representation of rotation in anti-clockwise direction is given as cos theta minus sin theta cos theta. Correct? This represents an anti-clockwise rotation. And we also learn reflection map. This reflection map having a matrix representation as cos 2 theta sin 2 theta and cos 2 theta, but it will be in minus over here. Correct? Okay. So this is nothing but a reflection map from a line passing through region making an angle of theta. Correct? So in this case, what we will do, we'll try to find out the matrix representation of this. This hint must be there with you because in the last video we discussed that a matrix representation of an orthogonal transformation is an orthogonal matrix. Correct? So over there was a hint. We are going to use that fact. So I know the matrix representation for an orthogonal transformation is an orthogonal matrix, and from that I will conclude that the matrix will look like this or it will look like this. Okay, let us start the proof. An orthogonal transformation, I have assumed T from R2 to R2 be any orthogonal transformation. Our aim will be to find the matrix representation of T with respect to the standard basis. Okay. So let us just consider the matrix representation of T with the standard basis be A, B, C, D. Correct? Where A, B, C, D will be what? A, B, C, D. My A, B, C, D will be some real numbers. Correct? Okay. Since my T is orthogonal transformation, I write OT, implies my matrix representation is an orthogonal matrix, Okay. Since it is an orthogonal matrix, I know the matrix representation transpose time the matrix representation itself is nothing but the identity matrix. So let us just use that fact. So it is A, B, C, D, that is transpose, and the given was A, B, C, D, and that is coming out to be identity, that is 1, 0, 0, 1. Okay. So this implies me what? This implies me A square plus C square is equal to 1. A square plus C square equal to 1. AB plus CD is equal to 0. AB plus CD is equal to 0. The same will be from this and this, correct? From this and this. The last is B square plus D square equal to 1. B square plus D square equal to 1. Okay. So here if you observe this and this equation, they are special equations, right? This A comma C satisfies my x square plus y square equal to 1. Correct? So this is nothing but what? This represent me a unit circle. Correct? This represent me a unit circle. And if A comma C satisfies this, that means what? It is a point on this circle. My A comma C is a point. Suppose it is point over here. This is nothing but A comma C. Correct? Then suppose this angle is theta. The angle with the real axis is theta. Okay. Then this A comma C can be represented in the polar form as cos theta sin theta. Therefore, my A is equal to cos theta and B is equal to sin theta. For I will write just for, okay, A for some theta, correct? Similarly, my B square plus D square is equal to 1 satisfies this equation. Hence, it will be somewhere on this circle only. Over here, suppose for an example, B comma D over here, and this line making an angle of suppose is making an angle of phi. Then similarly my B is equal to cos phi sorry, not B, it B over here, it should be C, right? It should be C over here. Okay, so B is nothing but cos phi and my D is nothing but sin phi. Okay. Now this second equation is unused till now. Let us just utilize this equation. So from that I get my cos theta cos phi plus sin theta sin phi is equal to 0. This is nothing but what? This is same as cos of phi minus theta is equal to 0. Now we know that the value of cos is equal to 0. Cos of some angle is equal to 0 if and only if that angle is plus or minus pi by 2, because it is 0 at 90 degree and it is 0 as minus 90 degree, correct? So I get to know my phi minus theta must be equal to plus or minus pi by 2. Okay, so from this we learn till this. Now we will be using two cases. From this I got my phi is equal to theta plus or minus pi by 2. Now what we'll do, we will consider two cases, and from two cases, like one is plus, one for minus, and you try to find out the matrix representation like this. Okay, so let us just go to the next page. I will consider two cases. Case 1, my case 1, if my phi is equal to theta plus pi by 2, let's see what happens. My matrix representation was nothing but A, B, C, D, correct? But the value of A was what? The value of A was cos theta, the value of C was sin theta, the value of B was cos phi, and the value of D was sin phi. From this we'll use the value of phi now. So it is same as what? Cos theta sin theta, cos this phi is same as what? This is same as cos of theta plus pi by 2, and this is nothing but sin of theta plus pi by 2, correct? This is same as what? This is nothing but cos theta sin theta. This is what? Sin theta plus pi by 2 is same as minus sin theta. Sin theta plus pi by 2 is nothing but cos theta, correct? The cos theta plus pi by 2 is minus sin theta. Sin theta plus pi by 2 is cos theta. So the matrix representation is nothing but same as what? This is nothing but, therefore T is what? T is rotation about origin with angle theta, and that is anti-clockwise direction. Okay, so in the first case we found it is nothing but a rotation matrix. Let us see the second case. The case 2, my case 2, I know my matrix. Case 2 was what? Let us just write in detail. So my case 2 is nothing but theta is equal to phi is equal to theta minus pi by 2. So my matrix representation was what? It was cos theta sin theta. Over here it was cos phi. Over here it was sin phi. Let us now write the value of phi. So it is cos theta sin theta, the value is cos of theta minus pi by 2 sin of theta minus pi by 2. Okay, so this is same as what? Just the 11th formula that you have learned in 11th standard, right? So from that you know this is same as what? This is same as sin theta, and this is same as what? This is same as minus of cos theta. Okay. So can you tell me what is this? Yes, the T is what? T is what? Reflection. Is it a reflection? Yes, T is a reflection from the line passing through origin, What is an angle? While representing in a matrix form, what we had was cos 2 theta sin 2 theta sin 2 theta minus cos 2 theta, and we used to say that it is making an angle of theta with the real axis. But in this case we have theta over here, so it is passing through origin and making an angle of what? And making an angle of theta by 2, and making an angle of theta by 2, correct? So in one case we got it to be a reflection map, in one case we got it to be a rotation map. Hence we can conclude orthogonal transformation in, therefore I will write therefore, in R2 is either a rotation or a reflection. Okay, so from this we conclude the theorem. Definitely the proof can be done in a different ways. Variation could be made if you consider different situations. Like over here you must have considered this is sine theta, this is cos theta, and similarly over here also on the place of B also you can make some variation. But this was the easiest way. You can have a variation, you will have some different kind of proof, but ultimately you will get the same things. Okay, so this was the last part in this section. In the next video we'll be discussing what is a characteristic polynomial. Okay, thank you so much guys for watching this video, and if you have any doubt please write in the comment box, give me your review in the comment box, please share it with your friend and subscribe to the channel. Okay, bye bye.